Hey everyone, it's John here. In this video, I'm going to explain everything you need to know for the SAT involving unit circles specifically. The reason why I wanted to make this video is actually because of a post somebody made recently in my free SAT community. Because someone here, I won't say their name, but they made this post and she went ahead and she posted a unit circle problem that she had seen. And you can see here, if you go over here, this got 165 comments and only 4 likes. What does that indicate to you? Well, this indicates that people were really debating this answer very heavily. Just a couple of people were really arguing about what the answer to this question was. So this makes me realize that I probably should make a video on this because a lot of you might be confused as for how you should be evaluating unit circle questions on the SAT. So in this video, I'm going to be covering everything you need to know about unit circle questions for the SAT and how to solve them if you do see one. If you want to know why you should trust me, I scored a 1550 on the SAT. I currently own the largest SAT Skool community, which is where this post was from, and I'm trying to make the channel that you're watching right now the best SAT channel on YouTube, which I think is a pretty good goal. Okay. As for unit circles, the first thing you need to know heading into this is what the unit circle even is in the first place. So I'll be honest with you, I've not really looked at this since like 8th or 9th grade. And for reference, I'm currently, graduated with high school. So it's been many, many years since I first learned about unit circles. And I was kind of hoping I would never have to use this knowledge ever again. But unfortunately, we are here and I do. So what the unit circle is basically a simple way, or I guess arguably simple, to figure out what degrees and radians must match up to when dealing with angles. If you're not familiar, you have this thing known as an angle, which is basically the distance of two lines when they're arranged in this kind of configuration. So if we have these lines here, the angle measurement would be this, the distance between those two. And now typically it is usually measured in degrees. So this could be like, for example, 30 degrees. But what you may not know is that another way you can write degrees is in this thing called radians. It's just another unit that can be used to describe the measure of an angle. So for radians, it's more just in this format. It's just regular numbers like 0, 1. And you could just say this many radians, 1 radian, 2 radians, 3 radians, 2 pi radians. That is what you would say for that. And just another way of describing the angle measurement. So for example, you could say 30 degrees, or you could say some amount of radians. I'm not sure exactly how much that would be. Actually, I can even check. So yeah, according to this, it would be equivalent to 0.52 radians. Now, if you're confused how I did this, I'll explain to you in a second. But yeah, this is what 30 degrees would be equal to if we convert it into radians. Okay, so yes, we have this list of things where we have the degree measurement and the equivalent radians, which you can get from these two numbers. They're not exactly these two numbers, but they give you the radian measurements. What many people might recommend you to do is just literally to memorize this entire unit circle so you can evaluate it when you get to the SAT. And while that may be arguably helpful, it might save a bit of time. If you don't want to go through that entire process, which I don't think you should have to do, you can also just use this method with cosine and sine. The thing with these is that the cosine of the radians is equal to the x unit of the thing, and the sine of the radians is equal to the y unit of the thing. I know that maybe doesn't make too much sense, so let me actually explain kind of what I'm saying here. If it is equal to, let's say, 3 radians, the cosine of 3 would be equal to the x unit here. So like square root of 3 over 2. And it's not exactly what that's equal to, but yeah, cosine of 3 would be this value here. And then likewise, the sine of whatever number would be the y value here. So you take the cosine or sine of the actual radians unit itself, and that is going to be giving you what these units over here would have to be. Now, we'll be drilling a bunch of problems on this in a second, so you won't have to be perfect at this just by learning it for the first time, but just try as hard as you can to understand that concept heading into it. Now, if you want to know how you can remember that cosine goes for the x unit and sine goes for the y, you can just think about a regular triangle. So this isn't, obviously too scientific of a way of looking at this, but cosine, as we know for triangles, as I say in my right triangle video, it's adjacent over the hypotenuse. And so thinking about adjacent, if you have the angle over here, adjacent would just literally be the one at the bottom, which makes sense for x because x is like literally going horizontally. It's going that way and it's going that way. So bottom both times. Meanwhile, sine deals with this configuration opposite over hypotenuse, which would be vertical, of course. This is going upward, so that's why sine is the upward one. Just a way you can remember it. So now let me show you how this works involving desmos here. So the big thing you need to know about problems like this is that you can go over here in desmos and click between radians and degrees mode. This is, probably the biggest time on the SAT where you really need to know this fact. I mean, of course it matters with, regular SOHCAHTOA as well, but for these problems, it's really, really important to understand this. So Pretty obvious what you need to do here. If it is dealing with radians, you put it in radians mode, which is what's going to be for the majority of these problems, just so you know heading into this. But if it's in degrees, then you go into degrees mode. So let me show you what I'm trying to say here. We have 30 degrees over here. We see that 30 degrees is equal to square root of 2, 1/2. If I do cosine of 30 degrees, we get this 0.866 number, which would be equal to square root of 3 divided by 2. Yes, so you can see here, here's how it's working. You take the angle measurement, you do the cosine of it, and that would be the x unit. Likewise, if I did the sine of it, we get this 0.5 thing, which of course is equal to 1/2. 1/2 is the same thing as 0.5. So now it should be making a bit more sense. But of course, if you have radians, you can just convert it into this other thing. Instead, you just are going to have to write this in the radians format. So like if you, for example, have like 0.5 radians, you can say sine of 0.5, and this would be the y unit. You can say cosine of 0.5, that would be the x unit. And we'll see some problems on this in just 1 second, as I said. Okay, so let's see this problem. Point P lies on a unit circle in the xy plane and has coordinates of 1, 0. So I would suggest when you see points in problems like this, just immediately write out each one. And you can actually even click this thing label, and then that allows you to put a letter for that point. So you can see here, this is specifically point P. So that is really useful. Point O is the center and has 0, 0. That's what you're typically going to see in, problems like this with the unit circle. So that there and then O. Then you have point Q, which is 0K for its unit. So that is that for a Q. And then K would also have to be a negative number. So we know no matter what, it's going to be somewhere like down here, which could be the positive measure of angle POQ in radians. So just to evaluate what this is trying to say, if you look here at the unit circle, this is basically like if we were trying to take this huge angle going from 0 all the way to this down here. So that is basically what is going on here. So you can imagine that for what this is supposed to look like. And that's what these points are trying to say. So the easiest way to solve it at this point here is that we can just take each of these different things that we get for the answer choices, do the sine and cosine thing on them, and see, does it match up with this K point? Is it somewhere in this kind of vicinity down here? So for example, I can do here cosine of 9 pi divided by 2, and then sine of 9 pi divided by 2. If I put that into this, it's going to make it into a point. And you can see here, this point would be above the thing. So that does not work. It's not in this vicinity down here. So therefore, that cannot be the right answer. A is out. If we do the second one, 5 pi, we do that there. And then for this one, we do 5 pi as well. We see now it's on like this side of it. So again, not where we need it to be. It needs to be somewhere down in this vicinity. So not that. Then we have 11 pi over 2. And we can see, yes, that is now in the vicinity. Theoretically, K could be equal to, yeah, let's say, just say like 1, in which case it would be the exact same thing as this green point over here. We know it has to be negative as well, so that's why K cannot like be up here. So we know C has to be the right answer, and if we were to try 6 pi, we get, P, which again would not be the right answer. So just to reiterate one more time in case it still doesn't make sense to you, cosine of the radians amount is going to be the x unit, and then sine is going to be the y unit. That's why I put it in this unit form here. Okay, this one here, we have a unit circle with the center at origin O again, so I can just write here 0, 0, label O, and then we have point A with 1, 0, so there, and the point B with these coordinates over here. And we're trying to see the measure of angle AOB. They say that it is P radians. What is the value of this stuff here? So now you can see we're kind of working backwards. We already have what the X and Y unit would be, and we're trying to figure out what would be the radians measure based off of that. One way we can do it is basically make a system of equations using desmos regression. So we could say here's something like cosine of P and then sine of P. And then we have to say that these must be equal to this exact thing over here. That should make sense to you if you understand kind of what we've been doing here. We're trying to see what value basically makes both of these true. Cosine would be the x unit, sine would be the y. We see here that the one that makes both those true would be 2.06. So therefore, we can just use that and we can say sine of P divided by cosine of P. That'd be negative 1.875, which would be equal to negative 15 divided by 8. One thing that I should mention is that you may think that you could just go ahead and split these up and say something like cosine of P is equal to like negative 18 divided by 17. That would not work because you have to think about it like there are multiple different values that could all make this exact thing true. You only find the right one when you consider both of the different things. You're trying to find a value where both cosine of P is equal to that and sine of P is equal to this. That's why I have to do the whole thing because it is a system of equations you need to use there. If you're confused about the desmos regression stuff there, I have a whole video on desmos regression you can watch to understand it a bit better. Also, I believe this is the problem that was posted in the community, at least a version of it, so you can use this as a good reference as well. Oh, we have this one here where we have an origin at 0. I'll just go ahead and write that as being 0, 0, because we always know that's going to be about that for these kinds of problems. And then it says it's rotated counterclockwise from the positive x-axis. That's not really as confusing as it sounds, it just says that it's like this, like a regular angle. And then it says here that it has, this amount of radians, where this is less than that, is less than that. So a bunch of information here that may seem really important. It's not really that confusing, but we know that the radians amount must be between 6 pi and 8 pi. And then it says it intersects the unit circle at 0 at the point a negative 1/2, where a is less than 0. So I can just go ahead and say here a and then negative 1/2 as well, and then put a slider for a. So what would be the value of A? They actually even just give us the radians. We see here that the radian amount is 43 pi divided by 6. So that makes this problem a lot easier than maybe it would have been otherwise. But okay, let's just think about what we're trying to find here. We're trying to find what the x unit of this would be. So we also have the radians here. So what we can just literally do is say cosine of 43 pi divided by 6 and see what that gives us. We have negative 0.866. We do know it must be negative because they say a must be less than 0, so that makes sense. And then we just go ahead and just see which ones of these match up. It's not really an easy way to do this in Desmos regularly. We just have to go ahead and try it out. So like that. Yeah, actually, just the first one I tried, negative square root of 3 over 2 would literally just match it perfectly. So I can just go with this. Just so I can show it, I just want to show you an example where it involves degrees, at least to a small extent as well. This is not going to be a very hard problem, but just so I can show it. So we have, again, the beginning being at this 0, 0, and they have A lying at 1, 0, and then point B is lying over here. So we have just all three of the points immediately. So good stuff. We have this configuration over here. What would be the measure of angle AOB? We are saying here in degrees. And keep in mind, you can do the exact same stuff as I've been doing in these other problems, just in degrees mode. All you need to make sure is that you're actually using these degree amounts, which are going to be like in the hundreds, whereas radians are typically like, 1, 2, 3, 4. So that is what we can use here. And we can just go ahead and literally just make another system where we could say here cosine of, let's just say, I guess P, whatever, sine of P. And then we have here equals negative 1/2. And then the other one, square root of 3 divided by 2. So we see 120, that is the only angle measurement that works, and we can go for that. I will say for a problem like this, if you did have it memorized, you might be able to save like a couple of seconds. Like you could just look here and see immediately that, okay, negative 1/2, 3/2, that must be 120 degrees. It's just right over here. But I honestly do not think the amount of time you're going to save with that is going to matter too much when you actually get to a unit circle problem on the test. Like probably even just thinking about the problem, having to think, okay, which, remember the unit circle again, which thing goes where, probably that alone is going to take you enough time that it wouldn't really be that effective. And speaking of which, it's worth mentioning that this is a very, very rare problem. Like it's very unlikely you're going to see this on the SAT. I've taken multiple SATs where I did not see a problem like this. So you may be wondering why I didn't make a video on it. Well, just because it is so confusing that if you do see a problem like this, you are absolutely cooked if you do not know this stuff. So though there's a small chance, it is very good to know. And I did even have a few people who told me that on the June SAT, they did see a problem like this, at least one of them. So good thing to know that, there may be a potential for seeing this on a future SAT, even if it's not super likely. Thanks so much for watching. Make sure to drop a subscribe on this video just so you see my channel again. Otherwise, the algorithm may never show you the channel ever again, which I know would be very unfortunate if this gave you any kind of value. Good luck on the SAT, and make sure to always stay Gucci.